Recording in progress.
We're now recording, and let me, okay, so some people are asking me if we are going in person. So that is not up to me. That's a, oh, hold on, let me not record this. Hold on. Recording, and we are going to share the screen. All right, so you can see here, let's take a look at the calendar real quick. Let's go to 372. This is 372, the sysadmin class. So the first 2 weeks, we've covered just a basic intro to Linux and a basic intro to scripting. Today, we're going to start a more formal, some people in here. We're going to start a more formal discussion on just Linux, which is I usually call or this lecture the UNIX way. So you can see that the UNIX way. And so we'll kind of talk about that. And then we'll talk about servers and services a little bit. Okay, so please mute your microphones if you haven't done so already. And then on the next day, today's Tuesday, yeah, on Thursday, you know, we'll finish up some scripting that we had, I think, plus you'll have another homework assignment where you have to do like Linux commands. I may also introduce the Wireshark reading, which is an interesting thing. And then next week, it'll be week 4, February 1st. So we'll get into cron. Cron is a really nice tool in Linux. It's a scheduling. So we'll learn how that works, learn kind of the semantics of how to configure Linux, or sorry, cron, and getting it to work. Okay. So, all right. So that's the calendar. So I just wanted to, I'd like to know where I am. Let's go now to Brightspace and take a look at the materials that I've posted on here. So this is Brightspace. All right, so I'm getting a whole bunch of emails about the whole being online, being not online. All right, so what I can say is, guys, if you have emails, it's out of my. Let me pause this. Recording. So I'm going to share now the Brightspace environment. All right, and let's take a look at 372. And I'll start grading your homework assignments this week, so you can be on the lookout for that. I see that you submitted your first assignment last Thursday, so I'll definitely start. I grade those, so you'll start seeing grades for them. All right, so let's go ahead, look at content, and let's just see what materials we have for this week. All right, so we've done this, and you have a homework assignment due on Thursday, right? So don't forget to submit that. Okay. So this is week 3, and we're going to look at services and tools for system administration. So that's really the idea. You also have a few slides or PDFs, the UNIX way. So I'll talk about this one today. But I usually have my notes already. So a lot of the things I say, they're usually in some slide somewhere. So just make sure you read through all of these. This is more the administrative side of sysadmin, so maybe not as technical. Workstation, servers, and services. Oops, sorry. All right. And then after that, you'll have some homework assignments this week. So these were copied from last year. So I'll just have to modify them, but it serves me as a reference. So just be on the lookout. I'll change these. There's a Wireshark document and some attached files. I'll talk about that. And then this is the main focus, I guess, lab services and tool services. So there's a lot. I'll probably break this up, I think. I'm going to break this up into a couple of modules instead of just one. Because I think I put everything here last time, but it's a little bit too much. All right, so we'll still do it. I'm just going to break it up into different modules probably. But anyway, this is kind of the materials for this week. And so we're going to start at the UNIX way. Okay, so we will start here, the UNIX way. You can see this is a PDF, I think, of just my notes. Downloading. Right, I think, yeah, so the trick with this one is you have to download the document. It looks blank like this on the Brightspace, but when you download it, there's information there. All right, so that's it. So let's start with the UNIX way. And it's really, you know, because this class is about sysadmin. Sysadmin is pretty big, but the focus of our sysadmin is going to be basically the Linux operating system, right? So I'm going to switch over to the whiteboard here. And we're going to talk about Linux in particular and, you know, this idea of the UNIX way, okay? So this we're going to do this week. All right, so what is this, the UNIX way? In your book, and in particular the Linux books, it'll start by talking about what is the UNIX way. And so this, you know, we have the UNIX way, right? And basically it's like the philosophy of Linux, you know, that somebody came up with, you know, this philosophy of how Linux should work. And then pretty much everything, it's like the conceptual design of Linux, and then basically everything that's implemented, it's going to be implemented around this idea. And basically the UNIX way is really, it can be boiled down to files, right? Or more importantly, we can just have a statement that says in Linux, everything, and I mean everything, is a file. So you might say, for instance, so you say everything is a file, and I'll say, yes, everything is a file. So is a text file a file? Yes. But a directory, that's not a file. Actually, in Linux, a directory is a file. And then you'll say, but what about a process? That's a file. You know, the scripts, that's a file. What about the commands I type on Linux? Those are files. What about a device, you know, like the keyboard or a printer? That's a file. So everything in Linux is a file, okay? That's really the underlying principle. And so, you know, that you should understand about the Unix operating system. And that's why that is called the Unix way. And when I say Unix, obviously I'm talking about the more generic kind of the parent, right, of all the different Linux distributions, okay, all the different Linux distributions. So files are central to Linux. So files are central to Linux, to the Linux operating system. And basically Linux has a hierarchical or tree-like structure for its organization of directories. Okay, so the Linux operating system starts at root, and then it's got all the different you know, directories, and everything is a file contained in that directory. So it's a hierarchical directory organization, and this is known as, this is root, this is known as the file system. okay, in Linux. And that's central as well, because if everything is a file in Linux, then the file system, which manages all those files, would be extremely central to it, if that makes sense. Okay, so that's really the idea. The base of this tree is the root directory, which I said over here. And I'm pretty sure I showed you how this works in Linux last week. Now, so the key ideas are then that everything is a file. The files are organized in the file system. And then given these files in this file system, you have this concept of access control. Access control in Linux, okay? And access control just has to do with basically the concepts of ownership and rights in the file system. Ownership and rights in the file system, okay? So that's the central idea that you have there. So in Unix, files have two owners, okay? So in a file, oops. A file in Linux will have two owners. Okay, one owner is what is called a user owner, and then there's also a group owner. Okay, so there's a user owner, and then there is a group owner. Okay, so that's the basic idea of every file in Linux basically will get this ownership. And the user and the owner can actually be independent, all right? They can actually be independent. So let's think of a scenario of why this might be useful, all right? So we'll think a little bit about just a simple scenario here. Let's call this example. Example. Okay, and we're gonna think and I think I have this problem already written down, so let's go to Brightspace. And we are. So you should be seeing this. So here, this is where I am, right? So file ownership. Sorry, I need to share this. Okay, so file ownership on Unix files have two owners, the user owner and the group owner. The user and group owners are basically independent. Okay, so let's think about a little scenario, right? It's not a quiz, just a little scenario here so that we can talk a little bit about it. So we're talking about how everything is a file, and then we're talking about how we have everything organized, all those files are organized in the file system, and then we're talking about how there's access control. Then we talked about how every file has two owners, a user owner and a group owner. All right, and now we want to understand why this would be important. So let's think of it with a scenario. So suppose Smith, who is in the chemistry group, so this is some organization, right? And we have Smith, who is in the chemistry group, and she needs to access to some files usually used by the physics group. So if you're the system administrator, how do you give Smith access to this file? So obviously it's some kind of server, right? In the system, but Smith, who is in the chemistry group, needs access to some files usually used by the physics group. So she currently does not have access. All right, so, should we make Smith a member of the physics group? Is that a solution? What are some alternatives that you can think of to give her access to this file? Do you guys understand?
You could give her temporary access, like a user that would give her access to the physics department, but it would eventually expire after she gets the file she needs or after a day or so.
So, yeah, what else? What other alternatives?
You can give Smith access to the specific files that you need, not the entire group.
Not the entire group. So how would you do that in Linux? Because remember that in Linux, you have the owner of you have basically access control for the owner, the group, and everyone else, right? Now, that's the thing that we want to understand how exactly we would accomplish that in the Unix operating system. You see that? So just giving her access to that file, how would you do that? How would you just give her access? Chmod, all right. Changing the permissions, sure, okay. How so?
I was gonna say you could duplicate the required files or something, just make them accessible in both groups.
Create a copy of the file. And then what? That's something. That's an idea, certainly. So how would you do it? So create a copy of it and then do what? So that actually takes us to, you might say, well, I have to look at this file, right? So let's then go back to the whiteboard and let's just look at this file. So if we think about it, let's say file 1, it's a very important file, .txt. This is the file that Smith wants to access, right? Now, this will have a user and a group owner, right? So we already established that Smith is in chemistry. Yeah. But this is physics. Now the owner is probably, Bob, let's say, whoever, somebody, right? So it's not her. And then we have the permissions associated with this, right? So the permissions would be, if you think about it, they would be, let me do this like this. So then here we have to establish 1, 2, 3, 1, 2, 3, 1, 2, 3. These three, and these three. They all relate to whether, this is for the owner, the user owner. This is for the group owner. And this is for everyone else. So let's just say other. Okay. So we have to, when you guys were saying, we got to do this or that, we got to do it here. Okay. So currently, let's say the user Bob, Bob can read, write, and execute the file. This is a file, so it's got a little dash. Now the group owner is physics. Physics can read and write, but not run it, let's say, for whatever reason. And then other can do nothing, absolutely nothing with it. So in this case, Smith, right? She can't access the file. So again, so somebody said, let's create a copy of it. Okay. Let's do file 1, copy.txt. But you see where I was going with the question? So now tell me, fill in the rest, right? Because Smith wants to get access to the file. You're saying she won't get access to this one, but we're going to create a copy just for her. So how would this work? How would you do it? What do you guys think?
You could create a new directory that'll just hold the files that she needs.
A new directory.
You can make a directory called employee files. And you could put a folder in there that would have like a placeholder file that can hold files from different apartments that people will use and need on a need basis. And then at the end, when they're not needed anymore, you have someone just delete the folders from that file.
Yeah.
So she'll request the folders from the department she's trying to get the files from. And then they will go to that file, and then she can access that directory and get the files. Then after she has the files, they'll get deleted.
Yeah. So there you're kind of thinking in a more generic way, but the point is I want you guys to start thinking about access control in Linux. So here in access control in Linux, we have to think about this file. Forget about folders, forget about other files. Just tell me, if I'm going to create a copy of this file, whether I put it in a directory or whatever, I have to fill in that. Do you understand? I can't just throw that file in there without filling that in first. Do you understand my point? And so this is what you have to tell me and fill it in for this problem. That's why I created a specific problem. You know, I just want you to tell me how I'm going to do this.
Right.
So how do I do it? What do I do? So somebody had said, create a copy. What are other, there are other alternatives too, right? So what are they? Now it's some kind of important file. You can't just like make the information available to everyone, right? It's a need to know or whatever, very critical trade secrets about the organization. All right. So, you know, Smith is an engineer in physics, but she needs some chemistry trade secrets there. So how do we do it? You guys understand my question? So who is, you have to tell me, what do these things look like? These are the exams, the types of questions you're going to get on the exam, right? Exactly like this. I'm going to come up with little scenarios and then, you know, you have to fill that in.
Well, I think all we have to do is change the permissions for other, since we don't want to exactly like change the group, you know.
So are you saying that now you
We
don't
just-
want to make the copy? Now you just want to stay with the original one? Is that what you
Well, we need the copy. We just
So you're still staying with the copy. Okay.
yeah, but we just need to change the other permission to readable. Like that's all it needs to be is readable.
So you want now in other, you want this to be like that, but for the copy. Yes?
Yeah.
Well, there's a problem with that. If you do that, not just Smith can read it, but everyone else. And even though you trust your employees in your company, this is an important file that not everyone should look at. Do you understand? Do you see the problem with what your suggestion?
Yeah, I do see that.
Yeah. So this is this is central, right, to access control in Linux. We have to understand how this works. But if you do that, which is equivalent to doing that here, right? And that's why I was saying maybe it's not necessary to create the copy, but if you want to create the copy, definitely not doing that, because that makes it more readable. So what else can we do then? What might be a better solution? Suggestions? Now, some of you have been writing about the commands that we will use, and we'll take a look at the commands in a sec, obviously. Some comments here. So somebody said, make her the user owner of the copy. Okay, make her user owner. Make her the user owner of the copy. All right, so if we make her user owner of the copy, then we're saying here, Smith is now the owner. What are the permissions here? What do you think? All right, so let's see.
I got another idea.
Okay, now there's somebody asking, can you have multiple user owners per file and different permissions per user? I don't really know how, no, you cannot do that. And then, okay, somebody said RWX, read only ideally if she only needs to see. Now that's a good point. So if she's owner, only read. And she can't write it, she can't do anything. What about the group here? What should the group be? What's the group there? Change her permissions so she could read the file she needs. No, permissions are not on a username basis. They're on a file basis. You see that? Does that make sense? You want to make her basically root, is what you're suggesting. No, you do not want to give one single person all the power in the world. You know what I mean? So now you could make her a sudoer, which allows for access control, but does she need to be a sudoer on a system just because she needs to read a file? You see that? Now remember, we're not talking about like we're going to email her PDF and something like that. We're not talking about that. We're talking about, and then she's going to open it on Windows or Mac. We're just talking about Linux itself, okay? In Linux, how we do things. And so this scenario kind of illustrates the point. Now, what's another alternative? Now, this was Fabian's idea, right? Create a copy. Now, what if we don't create a copy? What alternatives do we have? Guys? Change the user permissions with chmod. Of what? All right, so again, remember, oh yeah, so what I was saying is, what are alternatives to this? Add her to the physics group, but then she could potentially access other files that she doesn't need. So that might not be good. Yes, but that's, you know, we're kind of playing with what Linux gives us here, right? And one of the alternatives we have, as somebody said, is, you know what, this is so complicated, right? What, you know, man, that was complicated. So let's not create a file because that, you know, in Linux, let's just instead add her. Let's see, we could make a physics group that only allows her to read. We could make another group. That's definitely an alternative. You cannot have multiple groups per file though. Yeah, so we can, so basically this kind of, you know, if we had the copy, we could create a group and put her in that group, and that might be a solution where she only has read permissions, or just, you know, maybe just give in and just add her to the physics group. And then we could have, you know, that this might be the approach. All right. So now some of you are talking about the command. So let's go with that. We're just going to add her to the physics group. All right. So now let's think a little bit about some of the commands that we would be using for this. All right. So now that you kind of have a sense of what we're talking about, let's talk a little bit about changing file ownership. So changing file ownership. All right. So file ownership, the changing file ownership basically means we have some commands. So we've got some commands, and the commands are basically chown and also chgroup. All right, so these are the two commands that we will be using. So I'll just kind of go through this. Let's say that we're changing the ownership of the user. So notice here when I do this, I mean the prompt. So whenever I refer to the prompt, I might do one of three. So this one implies root or some kind of an administrator with administrator privileges. This means regular user, so no root. And this one will mean when I just mean the prompt, but I'm trying to keep it vague and not telling you if it's root or not root. Right, so just vague, if you will. So now we're going to go ahead and do chown, and then the new owner, and then file one.txt. Oops. .txt. Okay, so the new user here will be, it can be the username or user ID. All right, so it could be user ID or it could be user name. So in this case, if we wanted to adapt it to the example that we did before, so example would be chown Smith to the file, brass.txt, whatever, some name. Okay, so this is the command for changing the ownership of a file. Be careful when you do this. Remember, you guys are sudoers, so don't start changing ownership of files. I can guarantee you one of the biggest cause of problems in Linux is wrong permissions, wrong ownership of users, wrong access control permissions. That can cause you problems and you don't even know what's going on. And it usually comes down to that, the access control system. Now, let's say that you need to change the ownership of an entire directory. So you have a directory, a folder. So changing the ownership of entire directory. Right, so if we want to change the ownership of an entire directory tree, how do you do it? It's not going to work just putting in the path. So you can't, for instance, just say chown. Sorry. Sorry, I have a really bad cold. So yeah, so that's what somebody's saying, right? So just do chown username, yeah, directory name, and that's my point. That won't just work exactly like that, but I'll show you. It's actually pretty easy to fix it up. So let's say that's Smith, but now you want to change home. Not Smith, but some other one. Home. Let's say Harvey. My files. Okay, so you want to change that one. If you just run that command and yeah, exactly. So somebody provided the solution. If you want to change, let's say that you have this folder here, right? And this folder has a whole bunch of files, file 1, 2, dot, 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 and you want to change the ownership of all of those files in there, you have to add a little flag, which is going to be the -R flag, right? And I think it's a capitalized version of the flag. So it's going to be chown-r. Stands for recursive, basically. So this stands for recursive. And when you do that, you will in fact be able to operate on at a directory level. So you'll be able to change the ownership of all the files in there. This is actually very the solution for a lot of problems whenever you want to apply something to an entire directory. So for instance, if you want to remove a file, right? So let's say I want to remove RM file 1. That's no problem. You can just remove it like that. But let's say that you want to remove all the files in a directory. So for instance, I created a directory and I made a mistake. So I did like, MK directory, right? And I created a directory and then I created some files in it. And now I want to delete the directory itself. I will not be able to do it with the RM command because if it contains files in there. So what you can do is the same solution. You use the recursive approach. So I'm just showing you that this applies to a lot of things. So now you can do RM. Again, let's say home, Harvey, my files. But you're going to do the -R. Okay, recursive applies to a lot of things. Any questions? No questions? All right.
What exactly does recursive do for us?
It allows you to apply this command to all the files in the directory.
Awesome. Thank you.
That's what that's what it's called, basically. Now let's do another example where you want to change all the files in a directory to have a different username and group. Okay, so then we're going to go ahead and try that one. So I'm going to do, and let me just make sure I'm recording this. All right, so what I'm going to do now is I'm going to do chown-r, and then I'm going to do Smith : right? And that just means the user and the group. So then in this case, it's going to be the chemistry group or something along those lines. And we're going to change home, Harvey, my files. Okay, so we're going to change now in that folder the permissions of all the files for both the user and the group itself. Okay, so that's an important one. Now, if we just want to change the group, so let's change colors here. To change group, you can use, okay? And so we're going to say here, notice I'm changing this. So ch group, new group, and then file1.txt. So this applies to just one file where we're going to change the group. So the owner will stay the same. The owner will stay the same, but the user owner will stay the same, but the group owner will be different. Okay. So that's the idea. And this again can be the username or group ID. The group name or group ID. Okay. So the file access control is also known as file protection or file mode. You probably heard of it as file mode. Okay. also known as file mode. And basically, as we have seen, the three types of file access, there's actually a fourth one, are read, which is the R, write, which is the W, and execute, which is the X. Now there is a fourth one, which is called set UID, but this is not always common. And that basically means that this X will change to an S bit. But we'll talk about that later. And so these are the file permissions that you have. Okay. So the access classes, as I said, are user group and other, and we talked a little bit about that. So let's go back to this idea. So the first thing that you'll see in the operating system is actually either a dash or a D. Okay, whenever you have a file or something, an entry in the operating system, and that just means whenever you see a dash, this is a file. Whenever you see a D there, it's a directory or a folder. Okay, so it's a directory or a folder. So now let's take a look. I know you guys had mentioned chmod. So we're dealing with the permissions here. So let's take a look at, again, these. And we're going to look at the commands for that. And let's just say Smith chem file 1.txt. All right, so it's a file, which means it's got a, let me change color here. So it's got a little dash here, like that. And then we've got the permissions for the file, right? Now, if we want to make changes, we have a command called the chmod command, okay? This will allow us to make changes. So there's a couple of ways that we can do it. You saw it in the chat. Some people were writing numbers in there, and other people were writing letters. So basically, two ways of doing this. If we're on the command prompt or the command line, we can say u plus w file1.txt. Okay, so in this case, the U stands for the user, right? Now the available possibilities here for the access class. So the access class options are going to be, for user, it'll be U, as I just used it, which is basically the owner. And then for group, it's going to be G. And then for other, it'll be an O. All right, so these are the three options that we can use there in that scenario. So here we're using the U for user. And then we're saying plus the W, which is write, of course. And so basically what we're doing here is for that file one to the user, we are adding the W parameter. Okay, you see that? And this is a way that we probably had read permissions already. And this is a way that we can accomplish this. Now, another way that you can, and then obviously the options are, I'll just write them down here. The options would be G, O, plus, minus, and then also here, read, write, and execute. Okay, so these are the alternatives that you can play with to be able to change the permissions and access control of this file. The next thing we're going to look at is how do we the numbers that some of you were typing on the. So actually, before I describe it, Who can explain how those numbers work? I saw somebody wrote chmod and a number instead of the letters. So how do those work? And those are called, by the way, numeric file modes, because we said initially here that this is called a file mode, right? As we did it here, but we did it with letters. Now let's consider the numeric file mode. So let's see, there's a question on the chat. They add up to equal the permissions for user group and other. That's right. 0 for 1, 1 for execute, 2 for write, and 4 for read. Okay. What else? So actually, we're going to see a nice little handy way that we can do this. So let me just grab a little bit of coffee. Okay, so let's do a nice little example of how we can relate the letter codes file modes to the numeric file modes. So let's just say specifying numeric file modes. Okay, so specifying numeric file modes. So best thing to do is just to look at an example of this. So here, let's say that we want to assign permissions to a file, right? So we've learned already that the intuitive way is just to write the letters. So we know that we have to change the user, or that we can change the user, the group, and the other. So how might we relate the number codes? And what I mean by number codes is instead of doing it like this, somebody said, why don't you just do chmod 400 file1.txt, right? But we can't just memorize these numbers just right away. So there might be a nicer alternative that is something that we can always just figure out, right? And so if we take this little table, we can see how this could work. So let's create I think that should be enough. So here we have some file1 that we want to process. Okay, so we're going to first take a look at the mode. Okay, so that's going to be the mode. Then we have convert to binary. Then we're going to have convert to octal digit. And then finally, put together. So, kind of put it together there. So, and just, or this is just room for me to work it out. So first of all, we know that we have read, write, and execute. Read, I should say read, write, and execute, read, write, and execute, read, write, and execute. So those are all the options that we have available, okay? Now, what we're gonna do is decide which one of those should be active and which ones shouldn't. So let's start there. So let's say we wanna set read, write, execute for user, but we only want to set read and execute for group. And then for other, we only want to set read without write or execute, right? So that kind of makes sense. So then we can basically think of it in a binary way as 111, 101, 100, right? You see that? And then once we have this, then you guys know how to convert a binary to decimal. All right. So in this case, what we can do is we can work it out as this is going to be, if we remember that, in binary, this is like 0, 1, and 2, right? So then we're going to say 2 to the 0, 2 to the 1, 2 to the 2. You see that? So then 2 to the 0 is 1. 2 to the 1 is 2, and 2 to the 4, 2 to the 0 is 1, 2 to the 1 is 2, and then 2 to the 2 is 4. Do you guys see that? And then obviously we multiply it times the binary. In the next one, we can do 2 to the 0. This one will multiply to 0, so we avoid it. And then this one is going to be 2 to the 2, right? So this is going to be 4 and 1. And then all we have to do is think of that we're going to add them. Right? And then we can do so this is also adds up to like that. And then so this is going to be 4 plus 2 is 6 plus 1 is 7. This one is 5. And then we do the last one. And this is going to be, well, this is 0, this is 0. This is 2 to the 2. Okay, so that's going to be what? 4, correct? And then this one becomes 4. Yes, 754 is then the answer. So now, for instance, if I want to assign that permission in one shot with a number to a file, I'm just going to do chmod. This is 7, so it's 754, so it's 754 file1.txt. And that's the equivalent of having to do all of these, right? So that obviously that would be, so this is handy. For instance, let's say that you guys have a script, right? You're automating the process of changing the permissions. If we do it the other way, the file mode like this one over here, it's probably a whole bunch of a few entries that you have to have in your script. But as somebody said, if you want to use that 400, etc., and you want to do it in one shot, then you can, simply work out your little table over here, and it'll give you the numbers that you need. And so you will set all the permissions to the file in one shot. Is this clear, guys? Are there any questions before we move on to the next topic? All right, great. So now then, all right, so let me double check the slides just to make sure I haven't missed anything. According to my notes, I'm done with this part. All right, so this is cron. Okay. So I've lost the page here. Anyway, so let's, oh, I found it. Here. All right, so let's go to the notes. So let's go to Brightspace, I mean, and let's just make sure that I didn't forget anything. So we were looking at these slides here, right? And we covered this the UNIX way. So if you didn't take the notes, you can just read through this or print this out if you want. We've talked about that. Let me make sure. Yeah. Talked about the scenario of Smith. Okay, we talked about CHO and CH group. We talked about recursiveness in file permissions. Talked about that. Talked about this set UID. So notice that's set UID right there, but I haven't talked about that concept. That's a bit of a slightly more complicated concept. So we'll take a look at that a little later. All of this I've talked about. We did that example. Best practice. So I think I said this, but I'll remind you again. Usually, you know, file access problems are the most common. All right. So a lot of the time you'll struggle with something, and chances are the problem was access control. So a good way to know is to switch user accounts to sudo. So if you remember, sudo is what allows you, let's say, seed on your VM to escalate privileges to become an administrator. Okay, so if you're using an account and you're having trouble with something that's not working for whatever reason, chances are if you switch over to sudo, it'll probably work, and then you know, okay, it's an access control issue. So in conclusion, in Unix, it is safe to say that everything is a file, believe it or not. All manner of things in Linux are represented as files. So input and output devices are represented as files. Regular text files are files. Directory is also a file, which is basically a directory is just, if you think about it, it's just a file containing a list of the files in it. So it's like, you know, this is my path, this is where I am, and then these are the files that I contain. But at the end of the day, a directory is nothing more than a file listing files. Okay. Now links, that's something that I did not talk about. Excuse me. So links are a very important mechanism in Linux. So a link is a mechanism that allows several file names to refer to a single file on disk. All right, so this is important. For instance, one of the problems that you will have, your practical exam requires you, at least in the past, I've had you install a complex thing for Linux, right? It's usually the most complex things to install in Linux are things that involve distributed computers, like making a cluster of computers, something like that. So usually those are tricky because what happens is that you're installing software sometimes, right? So let's say that you need to access Java 2.8, right? But as you know, Java will, you know, let's say this .jre, but this file is going to be updated a lot, right? So chances are 6 months from now, it's going to be Java, you know, 2.9.jre. So if you have a whole bunch of scripts and programs that refer to that Java, so in a file, right, you're referring to Java 2.8. What's going to happen when you update that file is that you're going to have a problem, right? There's going to be an error. So what a lot of programs do in Linux is that you're just going to have a generic file called Java, a generic, you know, kind of like this. And then what you want is your file is always Java, but it's actually pointing to one of these versions of it. And this is usually then called a symbolic link or a link. In this case, it's a symbolic link. Okay, so what you have here is you have Java, and usually what it looks like in Linux is something like that, where that is pointing to Java 2.8. .jre. Your program, let's say that now you update it to the new Java. Well, you don't have to change any of your scripts or other files because those are only referencing Java. And then the only thing that you have to do is you're going to remove this symbolic link and you're going to create a new symbolic link. This time around to Java 2.9 JRE. Do you see that? So it's a simple solution because this will happen in the file system. You just create this symbolic link. You always refer to Java in all your files. So it's like you're looking for a file named Java, which doesn't exist, right? Java is a file, right? Because everything is a file in Linux. But again, that's just directories are also files. But in essence, it's not a real file that contains data. Instead, the thing that contains data is Java 2.9, that version, right? But by creating a symbolic link, whenever you do something like cat Java, you will actually see content, but it will not be the contents of Java itself because that doesn't have data. Instead, what you will see is the contents of Java 2.9.jre. And the reason why that works is because of the symbolic link. Does this concept make sense, guys? Are there any questions about symbolic links? They're very useful, in particular in this case, this scenario that I just mentioned. Any questions? No? All right, so it sounds like you get it. All right, so let's switch back to the PDF. Just making sure I covered everything. So that, links, as you can see here, a link is a mechanism that allows several file names to refer to a single file on disk. And that's also another thing is that multiple files, because you can see here this scenario, I called Java, but maybe another program calls it Java default, maybe another one calls it my Java variable, whatever. All three can be symbolic links pointing to the same JRE 7.8 or whatever version we're talking about. Okay, so that's it. So let's take a look at the next slide. Sockets. Now we did start talking about sockets on last week. If you remember, I talked about we were building a port scanner, right? All right, so there's a question here and it says, the Java is similar to Python. Example, we can't call any Python lines without calling them as Python 3. Java follows the same rule with its Java 2.9. I'm talking about a slightly different thing. I see your point. It's not wrong, but in a sense, I guess, yes. So usually, that's a good question, actually. I don't know when I call Python 3, if it's you know what? I'm gonna check that out because that's a good question. Let's open up the VM and let's take a look at that. His question over there. So I'm gonna start the virtual machine. So let me share this. Okay, so you should now be seeing the VM. So his question is, whenever you go into Linux and you try Python, is that a symbolic link? So let's take a look. All right, so let me. All right, so there's the VM. You guys are seeing it. I'm going to open up the command prompt of the terminal. And I'm going to cd into bin. And I'm going to do ls-l in here. And I'm looking for the letter P. So there it is. And if we look at this one, actually, right, we see that. So now let me just focus in on that one. So I'm going to do ls-l Python 3. And actually, let me do. So there we go. So this is what we were talking about. So if we look at this file, we should now be able to interpret it. So Python 3, it is root own, user own root, group own root. If we look here, instead of a dash or a D, it's got an L, which intuitively it means a link, right? Then notice the permissions: read, write, execute, read, write, execute, read, write, execute for everyone. So the user, the group, and everyone else can run it, which is true. You guys type Python 3 and it runs. However, when you run Python 3, this means that this is a symbolic link actually to Python 3.8. So to answer your question, Lynn, it is exactly like Python 3. So the Java example I was giving you is like this one. Does this answer your question?
Yes, thank you very much.
You see here, when I did cat, right, of Python 3, it gives me all this binary information. And basically what's happening there is that Python 3 does not have data of itself. It is just a link to the contents of Python 3.8. And why is this useful? Because Python is being updated constantly. There's, for instance, a Python 3.9. However, Ubuntu 20.04 currently uses 3.8. Makes sense. 3.8 is probably more stable, whereas Python 3.9, although newer, is probably less stable, still at the experimental stage. Okay. Okay. Any other questions? No. All right. Good. So, yeah. So that was a good question. So it allowed us to see, the permission. So let's go back to where we were, which is, I think, here. Sockets. Okay. So I want to finish up sockets. Okay, so now we were talking about links, so we talked about that over there. Now sockets, we talked about sockets briefly on last Thursday because we're implementing just to kind of see how we can do scripting in Linux. We were implementing a very simple port scanner, and to be able to use a port scanner, we need to use the socket module. and the subprocess module in basically in Python. Okay, so in Unix, there are special types of files used for communication between processes. And because the philosophy of Linux is that everything is a file, this is also a file, right? So sockets are basically files, and they follow the definition that, as you can see here, that they are special types of files which only serve as which are used for communication between processes. So you might have, for instance, a process like your text editor, right? And that process is processing, right? And you wrote a document, and then you want to print, and then you have a printer device, but to send the data from gedit to the printer, you probably have another process. So you send the data to that printer process, and then that printer process will send it to the printer device, and so on. And so this falls under the idea of sockets, which allow you to provide communication really between port numbers and IP address. Here we're just talking about the local host, but sockets usually can be thought of as tuples of IPs and ports, and also within the context of Unix, as special types of files used for communication between processes running in the background. So a socket may be thought of as a communications endpoint tied to a particular local system port, okay? Which, that's kind of the other thing we're talking about this week is services, and how services are tied to ports. So here you can see in the file system, we have home, etc. Bin. Now, we've looked at home a lot because we go to the desktop. We've looked at etc, where we have some file configuration files. We looked at bin today to find the Python 3 symbolic link. There's also a dev in your Linux, and that usually dev is associated with the files that control things like devices, like the printer, etc. And then a socket will allow you to make this communication from process to process, okay? So that's the idea. So you can see here in the diagram, we go from gedit to the process of the text editor to LPR, which is usually the process for the printer. And then LPR would send to the device, which is another file that would be able to write directly to a physical printer. So if this, oops, sorry. So if I do annotate here, this would be the device. And so this would send to that. And it's all a communication between the ports in these files called sockets, okay? All right, so let's move on. Okay, so we talked about sockets, and then that takes us to kind of processes, and this leads into the lab for this week, okay? So processes, in simple terms, so processes, in simple terms, a process is a single executable program that is running in its own allocated space, okay? So later on, we're going to talk about these things a little bit, but it's basically a process. It's got a process ID. It's an executable program. Obviously, it's associated with memory, RAM memory, and it is going to be running in an allocated space where it's got environment variables, etc. Now, within that, we have something called batch processes, which a batch process is something that is not associated with any terminal, okay? So for instance, these are actually called daemons, and a daemon is the keyword for a batch process. It just means the programs that kind of run in the background, right? But they're not associated with a terminal. So a program that's associated with a terminal is something like running a Python script, right? So I run a Python script. The Python script is running in the background. It's associated with that terminal. Apache or SSH or FTP, these would be batch processes which aren't associated with a terminal, but they are running in the background. These are the processes that get started usually at when you initialize the computer, when you start up your computer, etc. And here you can see I spelled out the word daemons, and that's really the the keyword as we are learning the terminology of Linux, right? So here a daemon are, what we call sometimes a server processes. They are often initiated at boot time that run continuously while the system is up, okay? And all they do is they wait in the background until a process requires their service, all right? So whenever we think of a Linux operating system as taking a role, right? So we talk about the server as a web server, an email server, a printer server, etc. Whenever we think, and there's a lot of services, by the way. So whenever we think of a process as this, we're talking about daemons, okay? So they're, basically they're processes or code software that's running in the background, waiting until a process requires their service. So here we can see web server, email server, DNS server. We'll do a really nice DNS lab where we have to configure bind9, which is the DNS daemon for Linux. And all of these will be associated with TCP or UDP, and they will be associated with specific port numbers. Okay? So you can see that here. This is a server. And then basically whenever a service is running, then you can see the port number is open. If you remember on last Thursday, I kind of showed you a way that you can see the open services, right? So I can do something like netstat, let me be clear here. netstat-na pipe grep TCP, and you can see all the ports that are open. So in this case, for instance, port 80 is open. That's a daemon, the Apache daemon. I can see port 22 is open. That's SSH, right? It's waiting. Port 23, telnet is also open, and so on. I can do this for UDP. I don't know that I have anything open, but there's a few associated with their own services as well. Okay, so that's a way to look at that. Let's go back to the slides. Okay, so we talked about daemons. So hopefully, this is a question I usually like to ask on exams. What's a daemon? So just pay attention to these definitions. All right, important Unix daemons. There's many, right? So pretty much any service. And now they have specific names. So there's the init one that, as the name implies, it runs on initialization. There's syslog. Now, if you notice, a lot of them they're basically the name and they add a D at the end. So what that means is syslog D is the syslog daemon, right? So what is syslog? Syslog is a daemon, a service for logging. So usually when you log and you create files and you're logging everything that's happening in the operating system, you don't always want to store everything in the same server. Sometimes you want all computers to communicate to a central server, a syslog server. And in that case, you can just analyze the data together. So that's an example of a daemon. Email, there's sendmail, for instance. That's a built-in service for email, basically, pretty simple and basic. Printing, LPD, right? So if you want to print cron, this is something that we're going to explore next week, the cron utility. And basically, as I said, it allows us to schedule tasks and run scripts, but run them without us intervening. So we're just going to schedule that the script should run every Wednesday at 3 a.m. Right. And so we're going to see how that works, but that's also associated with a daemon. And there are many more. I just provided a simple example here. Now, of course, whenever we talk about a process, we're going to be talking about some attributes. One important attribute of a process is the PID, which basically stands for process ID. So what that is if I go to the Linux operating system back again, you guys should be seeing the VM. So all you have to do is type, PS, and you can see there, it's actually showing me the PID of a couple of processes that are running. So this is 2516, this is 3105. So here it's saying bash. So it basically means the terminal that I am actually running is on there. You can kill these processes. This depends on a lot of things. Like I usually use killing processes when I'm running something on a GPU box, a process that, because what may happen is a process that runs a lot of data might take up space in the GPU memory. And when it takes up that space, you want to regain it back for the next problem. If you don't do that, the GPU does not immediately give the memory back. And so you're going to have a problem when you try to run another job and you don't have enough memory to process. Okay, so one nice little trick. Now, don't go around running this command just like that. Be careful what you do, but basically there's a way to kill a process, and it's literally the word kill. You type in the flag -9, and then let me pick one. So there's bash. So I'm gonna do 2516, kill it. You notice what happened. I literally killed my own terminal, and that's why I'm not there anymore. Right, when I open the terminal again, and I do PS, you can see again, there's the bash, but now, it created a new process. It's associated with a PID. Obviously, I could kill it again, but I'm not going to do it this time. But this is just an example of how this works. And you can do this with lots of things. And it's really a quick way of, getting rid of a process, basically. Okay, any questions about this? Yeah, so make sure that you select the correct PID. All right, so now, so as we were talking, process attributes, so we have a process ID, which is the PID. You saw me type in something like PS, right? And then if I want to kill the process, get rid of it, I can do, --9 4011. So that's the idea. Okay. All right. How much time do we have? All right. So let me see. Is this the last topic? Yeah. All right. So let's talk about this one. This is the last topic for today. And then on Thursday, we will go over the lab. Okay? I'm not really going to get into the lab today. So whenever you're talking about a program, let's say in this particular case, let's think of the scenario of a daemon, or some kind of a process that's running in the background, or running associated with a terminal. That's perfectly fine. But this is an executable program that's running. And now we've seen today that every file, right, in the file system, the static files that we were looking at have a user and a group owner. As it turns out, whenever you run a process, something that is executable in the system, now you have to think how this works, right? So you have a script, let's say a Python script, but that's a static file until you run Python 3, my Python script.py. At that time, you instantiate basically that text file into a process. So that process then will get like a PID, and it's a process running and executing some code. But that process also gets an ID associated with it, like an ownership, right? And in fact, as it turns out, it gets two. One is called the real ID, RUID. The other one is called effective ID, or EUID. So a process's real UID is the UID of the user who started it. So for instance, I'm Smith, my account is 1000, and I run this command, /passwd. It's an executable program, boom, I run it. When I'm running that file, remember, this is not the original static file, right, with owner and group. This is now the instantiation of that file into a process. That process itself will have this real ID and effective ID. Now, as the name implies here, a process's real UID is the UID of the user who started it. Now, additionally to that, there is something called the effective ID, the EUID. And the effective ID is the ID that is used to determine the process's access to system resources, okay? So basically what you have here is something like this. You have a process, right? You start it here. Your real ID never changes. So you're Smith in the system, you're always Smith, and your real UID is always 1000. That does not change at all. However, the effective ID can change. So the effective ID could be 1000 as well. So you have real ID 1000, effective ID 1000. In that case, they're the same. There's no change there, no problem. Basically, the permissions that you get when running the process are permissions of your own account. However, sometimes you can run the permissions with higher privileges, usually. So in that case, if you want to run the permissions with higher privileges, it could be like 0. 0, as you know, is root. So what that would mean is whenever you run a program where your root ID is 1000, but your effective UID is 0, it basically means that even though you're running it with full permission, so you have full access to all the resources of the operating system. Do you guys see that? Does that make sense?
That makes sense.
All right, so the question now is, why? Why would this need to happen? Can you guys think of a scenario where this might be necessary? Why not just use your real ID? Why do you sometimes initiate a program as real with a real ID, but then you get an effective ID, let's say a root? So what can you guys think as a scenario as to why you would need something like this? What do you think? Any ideas? All right.
Well, I was gonna say, I think the real ID is important if you're managing multiple, like, you're a sysadmin and then the company's using Linux, and then which user ran which program, which process.
Yeah, I agree with that. So for for accountability or for tracing, right? You want to know who they were. But why the effective ID? Why? What might be a scenario? So I'll close with this and let you guys think about it over the. So think about. So we'll close with this. I'm going to give you a scenario. Let's go to here. All right. There's a file. The passwd file. I think we actually looked at this one the other day. The passwd file contains the user information. You want to change something about a user, Smith or Mary or whomever, right? You want to change it. Let's imagine this file is just a text file. Text file with information. You want to change it, okay? But there's a problem. The user owner and the group owner of this is root. Do you see that? You are Smith. You're not in the pseudo-ors group or anything like that. You're just a regular user. You want to change your Smith home directory to something else, something like that. You need to access this file. Do you see that? You need to access it and make the change. But the problem is this file is root owned. What do you do? All right, so we'll close with this today. Think about it. Just take that idea with you and see if you can figure it out. Got it? Any questions?
I do have one quick question.
Go ahead.
Okay, so files have sockets, and these sockets, I assume, connect to other files.
Files do not have sockets. Sockets can be files, and then
Sockets can be files.
can be used by other processes.
Okay,
Okay.
that makes sense. Thank you.
All right. Anything else, guys? All right, I'm not hearing any questions. So as I said, think of this scenario, okay? This will lead us into an interesting conversation, but try to figure out, you have a passwd file. You want to change something about your username. I mean, it's you, right? You're not even changing someone else's user. You just want to change yours. Maybe your address or something is in there. You want to but the file is owned by root and the group is root, and you are not a member of root, and you will never be allowed to become a member of root. Only root can be in that group. So there's no way to do that. So think about what you could do to deal with this. All right. So Ursula, we'll stop here for today. I'm gonna stop the recording now.